तो कैसे हैं आप लोग? सब बढ़िया? All good? All right, so in this session, everyone understands how LLM works, yes or no? Everyone understands, तो चला जाऊँ मैं फिर? All right, but do you actually understand what goes inside the LLM? Have you heard about the dumb zone effect? Context rot? Context rot, all right. Have you heard about context engineering? Again, a beautiful concept. But how many of you deeply understand all this stuff? In sense, you can actually derive new concepts. Or let's say a quick example. How many of you have used coding agents? Literally everyone. और जो नहीं कर रहे उनका मैं क्या बोलूं? All right, but still, if you're using coding agents, then you might also know that coding agents, it's very hard to steer them. Sometimes you tell them, hey, you should do this. And coding agent is like, no, I won't do it at all. And the next time, if you say, hey, don't do this, but it goes on and does its all stuff, and most of the time it's forgetting all, like, it's very hard to control an AI agent right now, correct? How many of you have that frustrating thing? And how many of you have cursed an AI agent? Can I get a raise of hands? All right. Good. So, do you actually know the reason that why, even with the latest and greatest models out there, Gemini, 3.7 Flash, Fable saying, hey, I'm the AGI, and Soul saying, no, I am the AGI, and there is like different kind of benchmarks out there. But still, there is a problem. Yes? Have you all felt that? And how many of you have felt the amazing API pricing getting up to $200 in a one session? All relatable? And one more thing. When you hit a prompt, or let's say you are just typing in the chat box, hey, I want to do something, hey, Gemini, do this, 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 and hit enter. How many of you can actually forecast whether this particular prompt that I have given to the AI agent will work or not? Can we predict it before even hitting the send button or enter button? Can we do that? Huh?
To an extent, if weeks prompt होगा तो of course वो अपनी side से कर देगा कुछ ना कुछ.
Exactly.
उसको जितना precise करेंगे उतना better हो जाता है.
Good. But let's say you have written a very precise prompt. सब कुछ लिख दिया. Literally every single thing. Can you still predict it that whether it's going to be correct or not? It depends on the model, yes. But I'm asking a very fundamental question that all the models are having the same kind of effect that I'm going to tell you. So there are 3 basic laws, and just by knowing these 3 basic laws, just 3, you'll be able to deduce, oh, this is why my LLM is not working, or this is why, let's say you chat with an AI agent, the moment the project starts, everything is fine. The moment you start vibe coding, just like 4 to 5 turns, your project is just dead, right? Correct or not? So coming back to his point, even if you write every single thing in that prompt, still do you think it will work? Let's say I write, hey, I want to create a front end, I want to create back end. I have written 3 prompts, and I gave 3 prompts, front end, back end, system design, everything into one single prompt. And can you predict now it will work?
No.
No? Then what's the solution for it? Huh? Weather API से?
Basically RAG. We'll create project documentation and all in order to.
नहीं, weather API कहाँ से आ गया? Weather मतलब आसमान ना, आसमान वाली API. But temperature की तो बात ही नहीं की मैंने. Okay, was I clear? कहीं temperature की तरफ तो नहीं चला गया ध्यान सबका? Okay, so what I was trying to tell is, if you have a project and तुमने सब डाल दिया उसमें, will you be still able to predict that, whether it's correct or not? Cool. So that's what we are going to introduce right now. Too many questions, right? But बहुत simple intuitions है, because everyday technology will change, but these fundamental things will not change at all. Because, and you might be saying things like loop engineering, right? Memory. How many of you heard these things called memory is solved? My AI is like have infinite memory and all these things. But after this talk, you'll get a better intuition that, hey, these are some of the things which can never be solved mathematically. Forget about computer science. These are some fundamental mathematical problems. और हाँ, कोई research नहीं कर रहा मैं यहाँ पे. Don't fear. But yeah. All good? Is it interesting? If it's not interesting, then we can change the agenda. Because agenda hai nahi. It's like all of it's in my thoughts. And the moment you predict, then I'm going to change it at that time. Any other problem that you see with AI? We have to move fast. Because I have a time crunch of 35 minutes itself. Any other problem that you see with AI? और मैंने सब cover कर दिया है. Cover कर दिया? किसको लगता है cover कर गया? मान लिया cover कर दिया है. Can I get a raise of hands? All right, cool. And how many of you have at night 3 a.m. written some personal feelings to AI? Hey AI, why he's not replying to me? Can I reply that? Can I reply this? So वो वाले things भी हम cover करेंगे that hey, what you think that AI understands your feeling, it doesn't. All right, it's all coded. All right. So a quick highlight about me. So moving ahead, let's start with the most fundamental question of AI. All right. Now we'll move from ground up. Even if you don't know anything about AI, you'll still be able to connect. Number one, how many of you know about tokens? Tokens सबको पता है? What does token represent? Vectors. In simple sense, words. At bare minimum. We are just here for intuition. All right?
Energy.
Huh?
Consumption of energy that AI use.
Yeah, the basic currency of AI is tokens, right? Everyone understands that, right? Now, moving from, so everyone understands, so I won't go deep into the token, but moving on top, where does tokens live? In the context window of the AI model? Now, the first thing is, have you ever wondered that why your AI, and this is the answer to this, after a certain time, or you might have seen this IQ kind of behavior that in AI agents, IQ is relatively lower. But in, let's say, you are using Gemini CLI and Gemini app. In Gemini app, IQ is relatively higher, but in Gemini CLI, IQ is relatively lower, right? We have all seen that. That's why people go back to the web interface to brainstorm and then came back to coding agent to do all its stuff, correct? But this problem is very fundamental. The fundamental problem is, if you see this graph that we have, this is called the dumb zone effect. And this graph is for Opus 4.8 and Gemini 3.7 Flash. All right? So if you see this graph, your coding agents, you can just open your laptop and just see, let's say you are working with any coding agent and you can type /context, right? And the agenda, why I'm telling all this is because when you go to your companies, you build AI agents. Company is not paying you for the coding agents you use. Company is paying you for how much optimization you can do with a deterministic way or deterministic nature of your AI pipelines, so it gives a better output in the lowest cost possible. That's the main motive, correct? सब समझते हैं इसको? That's the main motive. But whenever you have a coding or any coding agent, that coding agent starts with the crowded zone. All right? And when you start with normal coding agents, or sorry, when you start with chat interface, they start somewhere around here. So if you see this green zone is called the reasoning zone. And the moment you start what's going inside the LLM brain. All right? Now I'll tell you why your 4 years of 4 years of bachelor's is important. All right? And why AI will, with this architecture, I'm not talking about future, with this architecture of transformers, why AI can never replace humans in terms of this human in the loop kind of thing. Now here's the thing, let's say I write this. All right, very simple thing. I hit enter and then, one second. All right, so now you can see it's scanning and it knows where to go and it's going. All right. So this is how an actual LLM works. Now, a thing for you to understand. Whenever you say make a website, all right, it just searches, okay, which cluster in which of this embedding space, because LLMs are in three categories. First is the inference layer, then is the reasoning layer, and the last one is the embedding layer. All the knowledge that you see in LLMs is at the embedding layer, and this is the embedding layer. All right? Make sense? Now, the problem with this this embedding space is, and why I say, oh, you have to study, because you have to gain your vocabulary. All right. The problem is, if let's say, how many of you are designers here? Okay, 1, 2, got it. And we are not. All right. So if you tell us, hey, make this website good, you know what's our vocabulary is to AI? Hey, not looking good. Hey, please make this better. Hey, please make this beautiful. Our whole vocabulary is just beautiful, make it better, and do certain type of stuff, right? Everyone agrees? Yes? But to them, they have a better version of its vocabulary because they have studied in the design space. So they know what exactly to type. So in simple sense, if you understand what an LLM is, it's just a compressed knowledge engine that you have in your hand. And it's your responsibility to study your 4 years of bachelor's and then hit the right keyword in this engine and get your answer. LLM says that, hey, I know everything about the world, but my limitations are, first, you have to ask or get the right trigger words. And second, I cannot connect the dots. Because only a human can step back and see, oh, this is the problem and this is the bottleneck. I should fix this rather than this. But LLM doesn't have this kinds of capability because it's a horse. All right? So keep this argument in mind. And that's why we say, hey, in a skill file, write your mistakes at the top, because in the middle you have this kind of internal knowledge that will take care of it, and what is the objective function at the bottom. Make sense? Anything that you want to argue with? I mean, I can be wrong. Correct? So this visualization is clear? So what is an LLM? LLM is so now you get the feel, right, that why certain people are able to make certain stuff, because they know the vocabulary. Same happened with, recently AI did a major breakthrough in Jacobian conjecture. So if you don't know, there was a conjecture in mathematics that was unsolved, and AI just did that, all right? And how it did that? Because the person who was operating that particular AI knew which exact polynomial or which cluster to target. And that's how AI was able to retrieve the knowledge, all right? You got the gist that, okay, AI is good, but it's like an echo chamber. AI is as smart as the person using it. So if you don't know the right trigger keywords, you'll not be able to make it. You can get somewhat there, but it's still all this clustering problem that's unsolved.
So how do you determine the right keywords for that particular LLM?
By studying your 4 years of engineering.
By studying 4 years of engineering,
Yeah.
you will understand how the structure of that LLM is there, right? But when we are prompting it,
Yeah.
so in that prompt, what word will actually be the most important? Like, is it going to be just the technical jargons that we in that particular domain?
Exactly. So that's the jargon. But if anyone has noticed, AI works like this, right? But if I do any other keyword, let's say, let's say I did this keyword, all right? It went back, and then it went to a different cluster. इतना गंदा नहीं दिख रहा भाई मेरे स्क्रीन पे, सही बोल रहा हूँ मैं, बहुत लैग कर रहा है ठीक है. So now you got a gist that it went to a different cluster, all right? And that's the answer to your question. Because the moment you feed multiple things into AI, that hey, build my front end, build my back end, build my this, build my that, all right? What AI has to do? It has to activate multiple clusters, all right? And there is a basic funda rule The basic rule is, if you try to trigger multiple clusters, it has to retrieve from multiple different embeddings. That's why U-shaped attention that's working inside the model, that fails. Then the dumb zone effect triggers, that fails. And when you have to trigger like multiple different vectors in multiple different direction, their average is taking out. And then you end up nowhere. And that's why you see, if you give a very big prompt, let's say you want to do, hey AI, build my front end and also do the sales. It will not do any single thing at once. You might have also seen that. If you give AI a bunch of different requirements and do this, it will do high level of all those things. But if you just really pinpoint at that particular feature, it will make that feature like the best. And why? Because when you give, let's say, hey, make the authentication page, it will go to the right cluster where authentication is defined and all the rules and logics are defined. And through that, it will able to get the right information or retrieval to you. So it's like the most fundamental problem in computer science is not this chip, this, that, etc., etc. It's all about search. If you really think about it, all the big companies that's there around the world, they keep solving the most fundamental problem of computer science, that is search. Instagram, best recommendation for reels or friends, people search engine. Google, knowledge search engine. Netflix, movie search engine, right? Every single company who made big was because of this searching kind of algorithm. So if you really see, AI has relatively solved the search, but still it's worse than Google. Why? Because Google can tell you all the stuff. But why it's best than Google? Because if you know the right trigger words, then you have to do that. But the cycle is, to get the right trigger words, you have to study from Google. Right? Make sense? And that's why you have to study. Because if you don't study, I don't want to go deep into that, but the crux of this understanding is, U-shaped attention, dumb zone will keep triggering. There is no way you can solve that, because that's a fundamental problem of math, not computer science. Then you have to craft your skill file. Now you see everything that's out there, loop engineering, this starts making sense right now. Because everything is derived from three fundamental concepts that I just showed you. And from here, whenever you keep sending a prompt, you'll have an intuition from get-go that why, before sending enter or before even making our AI pipelines, you'll be able to know, okay, why this will not work because of these fundamental problems. And to cater these fundamental problems, there are fundamental solutions as well, such as phased prompting. All right. So if you see this diagram, where is the diagram? 1 second. All right. So this diagram, you should actually structure your prompt in 3 simple ways: input, outcome, output expectation, and validation layer. This basically means that whenever you are writing prompt, to get the most out of that prompt, you have to write it in this way: input, output, and expectation. What this does, what this do to your AI agent? First of all, input, it can be anything. Let's take an example. Input, you want to make, let's say, landing page. All right. Then what is an outcome? Okay, landing page is kind of a taste based. Let's say you want to build the fastest inference engine. Let's say you heard about LightRT, right? Yes. LightRT you have heard. Let's make an engine that's better than LightRT. All right. We will create an engine that's better than LightRT. If you actually give this prompt, it will actually work. All right. So input is, hey, we have LightRT and we want to make this faster. That's your input. Outcome should be a metric. It can be any metric that you also do. Let's say for design people, it can be some sort of metric such as color hue or something. I don't know at all. So pardon me. Just forgive me if I say anything wrong. But it can be any metric, right? You guys have it in mind. For AI research, it's like the number of metrics that we have. Let's say we have outcome. Let's say I want to make LightRT an engine that's 50% faster. All right. And the validation layer is basically how you validate. All right. So I can validate it by running the LightRT. So that can be one prompt, and it's very focused prompt. All right. To one specific region of LightRT. Let's say I want to improve the KV cache or something else. If you don't know about KV cache, just remember why kuch nahi hai, phaltu bakwas hai sab. But in simple terms, KV cache is it's like ongoing topics. But imagine this thing that there is a system jisko hame faster banana hai, right? So in that case, you have to write in this prompt, one focused prompt. Now, this will create an internal loop inside the LLM until this validation is achieved, and that's a line you write. Until this particular outcome is achieved, you have to write this. All right? Any questions till here? But you can actually write multiple different prompts simultaneously. Input, input, input. And these are the concept of sub-agents. That you have one agent controlling multiple sub-agents, and in multiple sub-agents you have input, output, and validation. All right? Until that validation loop hits, until that outcome is achieved, you keep trying. All right? Got it? And that's why you shouldn't, at 3 a.m. write to ChatGPT, hey, ChatGPT, that guy left me. That girl left me. And you know why? Because the moment you write that, it will go to the Reddit cluster. And it will say, oh, very sorry. In this case, you have to leave. You have to forget about her or him. And that's why, because all these things come from the cluster, not because ChatGPT or Claude or Gemini understands you. All right? Sorry? Okay, got it. So you got the gist that what actually happens, it's just replaying the conversation that somebody else had on the internet. That, hey, when someone writes this, you're supposed to reply like that without understanding any context that you have. And then it just provides you the replayed conversation of someone else who had that with human to human. How embarrassing is that? That you're replaying a conversation of some people on the internet and validating your feelings. And that's why I always take professional help for these things. But coming to the, apart from my bad jokes, coming to the concept, input, output, validation. Now you can keep running these three things together, but okay, what is that thing? I think how many of you use coding agents? So whenever context limit hits, what triggers inside the harness? Compact? Amazing. Have you heard of compact? Compact basically says that, hey, if I am over here and my context window is just 160K, if I hit compact, I'll go back to 94 or I'll go back to 32K tokens. Why? Because it just summarizes all the conversation again. But in that summarization, everything is lost because it's a summarization. Most of the context, do not do this, do not do that, is lost. So what you should do here? What is the intuition? And the answer is in the RLHF, the U-shaped attention. What you should do to be able to basically overcome this? Think about it. Your brains are not smooth. Basically, there is research that if you don't think your brain curvatures become smooth and smoother. And that's what called brain rotting or brain rot content. That's why you're not able to give me the full attention. In between, your attention is also U-shaped. Only my jokes, my bad jokes, you are able to remember, but all right, cool. So here also, the three fundamental concepts that I told you, the moment you compact, before that, because RLHF is handling whatever is there on the internet, we don't have to worry about what to do. We have to worry about what not to do. All right. That's why you just say at the very first line that, hey, whatever critical mission or critical operation that you are doing, and why I'm saying this to write critical, because I have already experimented with, hey, what is important? Write all that down. And AI is like, hey, everything is important. I'll write everything down. All right. So, and that's why this again becomes the dumb zone effect, because everything is written, AI reads everything and just forgets. And that's why you have to. And then how did I arrive at that critical mission keyword? Is because there is a subject called software development lifecycle in the second year of college. And then in that subject, it's written that there is a mission critical operations or mission critical code that stays untouched. And that's why if you just give that, hey, only log mission critical stuff, it works. Why? Because of that keyword. So that's why I call these, or you have to study, because these keywords that you have, let's say mission critical or something, are the activation keyword or activation function for the LLM. Right? If you can think that way, that to trigger specific prefrontal cortex of a LLM or something like that. You have to give it certain type of keywords until it will not understand what you're trying to say. You got it? And that's why you have to keep asking LLMs all the questions. So you got the gist over here, right? Like, what's the problem? So that's why you keep compacting. And before compacting, you write all the mission critical things over there. That's why in this second layer of the harness, this particular here, this prod actions basically says that, hey, whatever is important, keep sharing along with the agents at the very first of the context. And that's why this systems called as memory was evolved. Memory systems, because AI was like AI, whenever you start a new session, it just forgets everything. All right. That's why you have the systems called memory systems. And what they claim is not memory. They basically claim that if we have a memory storage, I can retrieve it for you if the right keyword is triggered in my memory system. But the main question is that what are those right keywords? AI doesn't know. And that's why memory is unsolved. You got the gist? I'll repeat it again because it's $1 million problem. They say AI memory is solved, but our intuition towards AI memory is kind of, I would say, scrutinized, because AI memory was supposed to solve memory problems for AI. But the problem is we have AI memory that's essentially a vector database. When you want to access a vector database, you have to trigger the right keywords, but those right keywords AI doesn't know. And who triggers those right keywords? The LLM. And LLM doesn't know that these are the right keywords, and that's why it's not able to get to the correct memory location, and that's why it's not been able to again collate what was the previous conversations that we had.
So the solution to that would be कि हम correct keywords use करें, क्योंकि वो हमारे conversation.
What are those correct keywords? How will you create a function that?
If let's say मेरे को वेबसाइट पे एक कार्ड बनाना है,
हाँ.
जो टेक्निकली चार्गर्स नहीं जानते हैं, उन्हें ये पता है कि कार्ड के ऊपर कर्सर नंबर वो खुल जाएगा.
हाँ.
उसका नाम है ना hover animation.
हाँ.
I just have to use that hover animation. Doesn't
Correct.
solve the problem?
But you are thinking in terms of only one memory node. In a software or in a company like Google, Microsoft, this, that, the amount of documentation you have is enormous. Right? Even in your companies, if you go to any startup, within just 6 months, they have created enough knowledge that memory system starts failing because of the amount of documentation. And now with AI, bhai, aaj to pata nahi kya hi ho jayega. AI ke baad to it's like, hey, write this code, write the documentation. Write this code, write the documentation. So it's like with AI, you keep saying this again and again, and AI writes like, AI doesn't write all the critical, it writes everything. All the things from the scratch. If you tell it to create like a website, it will start writing React.js from scratch. So that's the problem. All right. So you got the gist of why memory. So the problem of memory is not to solve the search and retrieval. That's already solved, that vector space. The problem with AI memory is how do you find these right keywords so that it can be retrieved from the vector database? That is the question we need to ask when building AI pipelines. All right. So, and this whole thing is actually called loop engineering. This thing. This is called loop engineering. Now you know why loop engineering fails. Because we don't know the right keywords. People are saying, hey, create ChatGPT 7. It will not work because it doesn't know at all what are the things. Because if you really see what goes into, you say, hey, create ChatGPT 7, it will go to the ChatGPT cluster. It has some knowledge around that, and it will keep playing in that knowledge structure itself. It doesn't know what to do something else because of the previous tokens that it had. Humans can take one step back and see, oh, the problem is not in computer science. The problem is in cognitive research. I should look at this cluster and then try to translate these ideas into computer science to be able to create new solutions. Got it? And that's why, and this whole thing is called harness, and this is a production system that you have. All right? So these are all the things that you can trigger. So this is my Kaggle notebook. So this is one thing, and this is another graph. Now you'll be able to understand all this, because I don't want to make it overwhelming. So now you can see here is the retrieval. You can see the structure U-shaped, right? Makes sense? The U-shaped structure that we have. everything mechanism, middle in the behavior. Now you can see here, like this is literally U-shaped. This is what we call the U-shaped attention. And those are the tokens in, if I don't know if you are able to see. This middle unwanted layers are tokens to which AI model is not paying attention. So AI model doesn't know what's there. All right, because of the attention mechanism. Got it? And these are all the things. So these are the red patches or the needle in the haystack kind of things that you keep hearing. And now you know what actually they are. All right? So these are all the things that I wanted to talk to you about. But in a nutshell, now when you go to your companies, what's the first thing that you'll do is basically see the bottlenecks. Okay, whether our bottleneck is model or because models are smart, all right, then the problem might be in your approach of using the model. So whenever you start using a model or making AI pipelines, just keep asking, okay, I have written this skill file because you have to write it. Is this skill file too long? If it's too long, or whether this skill file is targeting just one cluster. If it does, then it's good. If it doesn't, then split that file. And I call this as a, वो नहीं होता सांप जो होता है ऐसे कर जो काटता रहता है. स्नेक गेम खेला है नोकिया वाला, नोकिया स्नेक गेम. तो उसमें होता है कि whenever you want to do a consecutive task in like a sequential fashion, what you do is you input your task, you add the output, you add the validation, and whatever is the output of the first task, that goes as input to the next task. And this way AI model is coherent between the task, and it will not use shortcuts, because at one time we have only given one task to the AI agent, and the next time when it sees the next task, it will know, oh, in the first this is the output, I should use that to invoke the next task. Got it? So these are all the items that I wanted to discuss about. Any questions?
Not that deep into AI, right? So this question might be very beginner level.
No, it's fine. Everything was beginner level here.
Yeah. You talked about keywords, and you said if we don't know the correct keywords,
Yeah.
how would we be able to get the required output? What if I get the keywords out from
AI model.
AIA, and then put that into AIB, which is my main AI?
Yeah. That will work. That's what we call as planning.
Vector database of those keywords as well, right?
So your question is, what if we get those keywords from AI model A?
Yeah, like whatever.
And what you'll write in AI model A?
I'll be getting from my B.Tech.
What you'll write in AI model A to get those keywords out?
Simpler language.
Exactly. There is a bottleneck. If you write, hey, give me all the, you can just try it out in AI model. Give me all the jargon words to be able to make ChatGPT.
I've tried that out, but at a very basic level. I've made up.
Yeah, that will be a basic stuff, right?
I put that to Claude.
Yeah.
So maybe it's the same answer to his question, that this is very basic, and bigger companies it's harder. So that might be the answer, but just my question.
That's the answer. The answer is the first step. The first step, you will write a very basic prompt. Hey, I want to create ChatGPT 7. Just go to, even if you write, hey, go all over internet and give me the right keywords. At max, it will say transformers, ReLU, softmax. Then it will talk about loop transformers, this, that, etc. All right. Then you take those jargon words and you put that into another. And at max, it will go to the same clusters of transformers, this, that. And it will keep progressing, even if you do it for infinite times. Exactly. And it's actually worse, because you ask the right keywords, it will give you 7 keywords in 7 different directions, 7 different clusters are being hit, and you get the degraded response from, even if you just write on like ChatGPT 7, hey, create ChatGPT, it would be better than writing, hey, create ChatGPT 7 using these architectures.
Okay. But what if we provide the document of that code?
If you provide the document that has all the answers written inside, then that document is generated by a human, not an AI.
No, like you mentioned that every time we are building something, we are also documenting using AI, and it is always doing from scratch. So
okay, you're saying while developing, we create documentation as well? and then we do the next thing. We had done that already. And that's why all these experiences coming from that drastic failures. Even we tried that. We wrote an AI engine for like 6 months. We said that, hey, now AI will handle everything because AI can create documentation, AI can write code. After 6 months, we have to rewrite the whole code base. And you know what was the major challenge? AI was not able to comprehend its own comments. Why? Because of the dumb zone effect. These concepts are 3, but it answers a lot of questions around AI, across AI. And that's why we were not able to do that. And that's why we have to keep looking at every single engine, now we don't do that at all. Because we tried it once, 6 months into the line, many bugs, AI told that it will solve, AI so wo kya meme aata hai? There is a meme on Instagram. मैं करके देता हूँ तो करता क्यों नहीं है? तो करना. तो ये वाला. So that's the meme that you get after coding like 6 months with AI and then rewriting the whole code base. So if you want to connect with me, so this is my website, systems. Okay, I'll just write it down. And all of my highlights. यार इन लोगों ने वैसे तो नहीं किया है कि भगाने के लिए प्रोफेसर को ताली बजा देते हैं और मेरे को तो वही लग रहा है. मजाक कर रहा हूँ यार. मैं मजाक कर रहा था, ठीक है, मतलब ऐसे. So this is my Instagram, or like anywhere the handle is this, and my website is this. All the things that you see across the stuff is either on this handle or either on this Instagram channel, or even the Kaggle notebook that I showed, through which you can fundamentally deduce any AI model capabilities, is also in that Kaggle. So I think that's all from my side, and I hope that has provided a better intuition and a new way of thinking into AI models rather than just sticking to skill files and stuff. All right, cool. यार फिर से भगाने का मजाक कर रहा हूँ यार. All right, so in the end we'll do one. So in the end, after every talk, I'll do one thing, is we shout the event name. We have energy?
Yes.
Do we have energy?
Yes.
Do we have energy?
Yes.
All right. So, Cloud Extended? Google, are you extended?
Yeah.
All right, cool. So, on the count of 3, we'll do, let's do a, क्या बोलते हैं उसको, testing. Let's do a QA test before going to production. So, what we'll say? Google I extended New Delhi. All right. So 3, 2, 1. Google. All right. So now let's move to production. All right. So 3, 2, 1. Google. All right. Chalo. Thank you guys. Thank you so much.